Section 6.4 is on slope-intercept form of the equation of a line, and the slope-intercept form of the equation is the y equals mx plus b form, where m represents your slope and m is the coefficient of your x, and b is the constant term in your equation, and that's equal to your y-intercept, when it is written in the form y by itself equals your x term and your constant on the other side. So if we look at a few examples, the first one asks you to create a table of values for this equation. So if we create a table of values, we just pick the x as -5, so that would be 2 times -5 plus 1 would equals -10 plus 1, which is -9. And then if you plug -2 in there, 2 times -2 plus 1 is -4 plus 1, which is -3. 2 times 0 plus 1 is 0 plus 1, which is 1. 2 times 2 plus 1 is 4 plus 1, or 5. And 2 times 3 plus 1 is 6 plus 1, or 7. So if we plot those ordered pairs, we have an x of -5 goes with a y of -9, which would be this point right here. X of -2 goes with a y of -3, which would be right here. X of 0 goes with a y of 1. X of 2 goes with a y of 5. And x of 3 goes with a y of 7. Little off there, sorry, Kent. Okay, so if we connect those, you do see that it forms a straight line. My line's a bit squiggly, but that's all I can do about that. Okay, so if we look at the questions here and identify the slope of the line, if you take any 2 points on that line and actually calculate it, then I'll have to pick 2 points that I use because the line is so squiggly. But if I go up from this point here to this point here, that's up 4, 1, 2, 3, 4, and right 2, so that would be 4/2, or slope of 2. And that matches what we just did in our investigation in section 6.3, that we should get a slope that's the same as the m value in our equation. And the y-intercept for our line is actually at 1, and that matches with the 1 in our equation as it did in the investigation in the last section. And then if we use that knowledge to answer the following questions, we can easily see that the slope of this equation here, number 2, it's written in the form y equals mx plus b, so the slope should be 2/3, and the y-intercept should be the constant 4. In b, it's in the form y equals mx plus b, so the slope would be -2, and the y-intercept would be the constant, which is -1/3. And the last one, the slope should be 3/4. Again, it's written in the right form, y equals. You always have to check that first. And then the y-intercept in this case would be 0. So the next topic is finding the equation from a graph. So we know that the slope-intercept form is a form of a linear equation. So basically, if we can figure out the slope from the graph and the y-intercept from the graph, we should be able to find the equation. So the first step there asks you to determine the y-intercept, which for this particular graph, it crosses over the y-axis at -4. So that means our b value is the same as our y-intercept, so it should be -4. And our slope, if we count the rise and run, again the x and y-axis are labeled in the same units. So if we go up 2 and right 3 to get from this point to this point here, we have a slope of 2/3. So now we've got our m value and our b value, so it's easy to write the equation y equals 2/3 instead of m, so 2/3 x plus our y-intercept happens to be negative, so it will be 2/3 x minus 4. So now we're going to basically find the equations of these graphs that are provided here. So the first one, again, just checking each of those graphs, they all have the same scale on the x and y axis, so we can count rise over run using every block would be one unit. So from this point to this point, we have a rise of 1, 2, 3, up and 1 to the left, so that would be -3/1. And the y-intercept is at 5. So our equation should be y equals -3x plus 5. We're just substituting the m for -3 and the b with 5. So then we check the next example in b, the slope. We use 2 points that are provided there. From the one on the y-axis at -4, you go up 1, 2, that's a positive direction, and then to the right 1, 2, 3, 4, 5. So that would be a slope of 2/5, positive, and the y-intercept would be -4, which would mean the equation would be y equals 2/5 x minus 4. And the last one, the slope, using 2 points, would be from this point up 1, 2, 3, and then over 1, 2, 3, 4. So that would be a slope of 3/4, but negative, because we went up 3 but left 4. Or you can just count rise, count run, and notice that the line is falling to the right, so therefore it would have a negative slope. And the y-intercept is crossing over the y-axis at 3, so therefore the equation would be y equals -3/4 x plus 3. Question number 2 says the graph of a linear function has a slope of 3/5 and a y-intercept of -4. Write an equation for this function in slope-intercept form. And that's easy to do because we know the slope and we know the y-intercept, so it would just simply be y equals 3/5 x minus 4. Question 3, you're given that the slope is -1/2 and the y-intercept is 3, so that again would just be y equals -1/2 for the slope, so that goes in for m, and 3 for the y-intercept, so that goes in for b. Question 4, how can you use the slope-intercept form to graph a line from an equation? You would start with the y-intercept as your starting point, and from this point use the slope, the rise over the run, to find other points on the line. So we're going to use that method now to graph these 4 equations that are given. So the first one, we need to identify the slope, and the slope in this case would be -2, which you might want to write as -2/1 to help you with your rise and your run, and your y-intercept would be 1. So we're going to plot the y-intercept and then count slope. Up to left 1, up to left 1, or we could have, from our starting point, our y-intercept gone down to right 1. And there's the first line. The next one, the slope, would be 2/3 but negative, and the y-intercept would be 6. So we start at 6 on the y-axis, and down to right 3 will give you a negative 2/3 for the slope, down to right 3 would give you another point, so that the slope is negative 2/3. Next one, the slope just has a negative in front of the x, so that would mean that the slope is negative 1. And again, you might want to write that as negative 1/1. And the y-intercept would be 2. So plot your y-intercept of 2, and then your slope would be up 1, left 1, up 1, left 1, or from your starting point you could have gone down 1 first, but then you'd have to match it with the right 1, down 1, right 1. And you can see that the graph is a line with a negative slope because it's falling as we move to the right. And the last one there is slope is a half, and the y-intercept is negative 2. So if we plot the y-intercept of negative 2, and then count slope of up 1, right 2, up 1, right 2, or we could have started from our y-intercept and gone down 1, left 2. So negative over a negative makes a positive as well. And there's your graph. Okay. So another thing you should know is that if you're trying to satisfy an equation with points, basically any points that satisfy the equation would be points that are on the line. So when you plug in an x-coordinate, y-coordinate for any particular point and it makes the equation a true statement, then you know that that point is actually on the line. So the first example says, using the equation 3y equals 3/5 x minus 3, verify that the point -5, -6 is a solution. Okay, so this basically means if it's a solution, it means that it's a point on the line. Okay, so we'll start off with the equation y equals 3/5 x minus 3. So I'm just going to kind of divide it into two columns there. And the y side would be -6. And the other side would be 3/5 of -5 minus 3, which is the same thing as 3/5 times -5/1. You don't have to show that step, so that would give you -15/5, which is going to be -3 minus 3, which is in fact -6. So therefore, the left-hand side equals the right-hand side, and -5 -6 is a solution to this equation, which means it's a point on that line. So we've got a couple of examples here to try. And the first one says to verify that the equation of the line graph passes through the point indicated. So the first one has equation y equals -2x plus 8. So we kind of start off with the left side equals -4. It's the point that we're using right here. And the right hand side equals -2 times the x-coordinate at 6 plus 8 in your equations. Work that out, you get -12 plus 8, which is -4. So therefore, since the left-hand side equals the right-hand side, that is a point on the line. So the next example has an equation y equals negative 2/3 x, and that's actually a plus 4. Looks kind of like a minus, but the plus is right on the grid line there, and you know it's plus 4 because we know that the y-intercept is 4, and that should be the same. This number should be the same as the y-intercept. So the left-hand side, if we use that point, would be 6, and the right-hand side, if we use that given point up here, would be negative 2/3 of negative 3 plus 4. And negative 2/3 times negative 3 is the same as negative 2/3 times a negative 3 over 1. And when you multiply fractions, you multiply tops, and you multiply bottoms. So you're going to get a positive 6 over 3. Negative times a negative is a positive. So that gives you 2 plus 4, which is 6. So therefore, left-hand side equals right-hand side. And that means that negative 3, 6 is a point on the line. Alright, this next section is a little bit harder. It's getting into finding the equations of lines given certain information. You're not given directly the y-intercept and the slope that you can plug right in for m and b. So you're given other information. So for the first example there, it says determine the equation of the line. So when you see equation of the line, the only form we know right now is y equals mx plus b. So that's what we're thinking. And it says the y-intercept is negative 3. So right away, we can fill in the b value to be negative 3. But we don't know the slope. Instead, though, we are given a point that the line passes through. So if the line passes through a point, that means that when I sub those coordinates in for x and y, as we saw on the last page, that should make a true statement. So we use that. We just plug in first. We're going to replace the y-intercept with the negative 3, and then we're going to use the coordinates of 1 and 5, 1 being our x and 5 being our y, and that's going to give us 5 equals m times 1 plus 3. And this is supposed to be, both sides of the equation are supposed to equal each other if that is in fact a point on the line. And because it told us there's a point on the line, we know then that 5 has to equal m plus 3. So therefore, just move that up a little bit, m must equal 5, take away 3. We just isolate the variable by bringing the 3 over to the other side or subtracting 3 from both sides, whatever way you want to look at it. We end up with m equals 2. So that gives us an equation of y equals 2x minus 3. The second example gives you the slope this time and a point. So you kind of follow the same pattern. Again, determine the equation of the line. So right now the only equation form that we know is this form, slope-intercept form. We know the slope, so right away we can fill in m is 2. This time we don't know the b, but we do know that negative 1, 4 is on the line. So that means that when x is negative 1, y should equal 4. So we can plug in 4 for the y and negative 1 for the x and know that this equation is supposed to be a true equation, which means that 4 has to equal negative 2 plus b. And if I want to get b by itself, I want to add 2 to this right side of the equation, and whatever I add to the right side, I have to add to the left side. So that means I got to add 2 to the left side, and it cancels on the right side. So then you've got b is 6. So therefore your equation would be y equals, the slope was given to us as 2, and we just calculated the b value to be 6. And now the information that we have matches that equation. So we're going to try a few more examples here. This one here kind of gives you the form of the equation and plugs in the y-intercept as 3 for you. So we got a little bit done on this one already. So we got y equals mx plus 3, and we're going to use that point. And this being our x, this being our y, so when x is 1, y should be equal to 2. And that equation should be a true equation. So 2 equals m plus 3. And again, isolate the m by subtracting 3 from both sides. Subtract 3 from the left side, you're just left with m. And then subtract 3 from the other side, you're left with negative 1. So your equation would be y equals negative 1 for the x, for the m, I'm sorry, negative 1 for the m, so that would be negative x, and plus 3. In equation 2, you are told that the slope is negative 3, and that's plugged in for you already, and you have to use your point to help you find the y-intercept. So your point is negative 4, 5 again, x, y. So when 5 goes in for y, and negative 4 goes in for the x, this equation should be true, which means 5 should equal 12. This will be a plus sign. Plus b. And you want to get b by itself, you need to subtract 12 from both sides. So that's going to give you b is negative 7. And therefore your equation would be y equals negative 3x minus 7. That doesn't look like a 3, but the more I try to fix it, the worse it gets. Well, it's the best I can do. So example 3 asks you to find the equation slope-intercept form for the line which has a slope of negative 4 and passes through the point negative 2, 5. So same type of problem. We know the slope is negative 4, so that goes automatically in for m. And we have to find b using the point. So we know that the point is negative 2, 5. So there's our x-coordinate, there's our y-coordinate. So this equation 5 equals negative 4 outside of negative 2 plus b. Just simply plug the x value in as negative 2 and y value in as 5. That should be a true equation. So therefore 5 has to equal 8 plus b, which means we got to subtract 8 from both sides to get b by itself. And that gives you a b value of negative 3. So therefore your equation is y equals, slope was negative 4, x, and the b value, the y-intercept, was negative 3. And that's your equation. Question 4, very similar again. So y equals, we know that the slope is negative 3/4, so we fill that in right away for m. And then use the coordinates negative 2, negative 8. So negative 8 equals negative 3/4 times negative 2 plus b. So that's negative 8 equals, that's going to be 6 over 4 plus b, which is going to be, if I reduce that, 3 over 2 plus b. So now I got to subtract 3 over 2 from both sides. And I can write that as negative 16 over 2, because that would be negative 8 over 1. Put over a common denominator of 2 would be negative 16 over 2. And that gives you negative 19 over 2 for the b value. And that means that our equation would be y equals negative 3/4 x minus 19 over 2. Okay. So if you're not given the slope or the y-intercept, but you're given 2 points on the line, you should still be able to find the equation of the line, because if you've got 2 points, you can find your slope using your slope formula, and then you can plug the slope in for your m, and then use either one of the 2 points, because they're both points on the line, to figure out the b value. So let's try an example like that. So the first thing we need to do is calculate our slope, which in this case, using our formula again, just to remind you if you've forgotten, is y2 minus y1 over x2 minus x1. So that would be 2 take away 4 over 8 take away 3, which is going to be negative 2 over 5. So you would have y equals negative 2/5 x plus b so far, because you know the slope, but you don't know the y-intercept. So then you can use one of your points. So this will be step 1. Find your slope. And step 2 would be to take your point. I'm going to pick the first one, 3, 4. You can pick either one of them because they're both points on the line, and then you just solve the equation with the y substituted with a 4, the x gets substituted with a 3, and then that gives you 4 equals negative 6 over 5 plus b, which is going to give you 4 plus 6 over 5 equals b. And then if you put that over common denominator, that's understood to be over 1, so that becomes 20 over 5 plus 6 over 5 equals b, so b is 26 over 5. So step 2 is use your point. To find b. It should say once m is replaced with the slope you found in step 1. And then the last step is your equation, which would be y equals negative 2/5 x plus 26 over 5. So I'm just going to move that up a little bit and squeeze in there. Step 3, write your equation. Okay, so here's some examples to try. So the first one, you're given 2 points, 2, comma 5 and negative 1, comma negative 4, and you're asked to find the equation of the line that passes through those points and write your answer in slope-intercept form. So the first thing, step 1, is to find your slope, which is negative 4 minus 5, again y2 minus y1 over x2 minus x1, and that gives you negative 9 over negative 3, which is positive 3. So then you sub that into your equation for m, so y equals 3x plus b, and then you use your point, either one of them. I'm going to pick the 2, 5, because it doesn't have any negatives in it. A lot of times I make silly mistakes when I'm using negatives, so if I can avoid them, I do. So 5 equals 3 times 2 plus b. Just sub in your x value for your x value with 2 and your y value with 5. So then you've got 5 equals 6 plus b. To get b by itself, you need to subtract 6 from both sides. So b is negative 1. And therefore your equation, this is putting all that together. You've got y equals 3x minus 1. Another example. So the slope, start off with the slope, is negative 7 minus a negative 2 over 2 minus 4. So that becomes negative 7 plus 2 over negative 2, which is negative 5 over negative 2. And the negatives cancel each other out, so that's 5 over 2. So then you've got y equals 5 over 2x plus b so far. Then you're going to use one of the points, doesn't matter which one, I'll just pick the first one. And you put the y and the x into the equation, so you've got an equation negative 2 equals 5 over 2 times 4 plus b. X is replaced with 4, y is replaced with negative 2. And then negative 2 equals, this becomes 20 over 2 plus b, which is 10. And then you want to get the b by itself, so you subtract 10 from both sides. And you're left with b is negative 12. So your equation then is putting it all together in your y equals mx plus b form, where m we found was a slope of 5 over 2, and b we found to be negative 12. Okay, the last set of examples is just basically kind of combining some of the stuff we did in Chapter 5 with what we're doing here in Chapter 6. So the first question is about a local skating group selling tickets for a skating fundraiser, and a ticket to the event costs $8 and the cost to rent the stadium is $200. So the first question, part of the question asks you to write an equation for the profit in dollars on the sale of tickets. So if you know anything about profit, profit is basically what you take in or your income, I guess, minus your expenses. That's the basic idea behind profit. So if we want to come up with a profit for this, they basically have to, the amount of money they're going to take in would be $8 for every ticket sold, so that would be 8t. But from that would be our income, we have to pay for the rental, so that would be minus 200. So in this case, T represents the sale of tickets, how many tickets are sold, and P represents the profit in dollars. So in question B, when they say if 87 people attended the event, what was the profit? You're looking for the profit, so you're looking for P. And you know that T is 87. If 87 people attended, that means 87 tickets were sold. So the P value, when the T value is 87, would be your profit. So 8 times 87 is 696 minus 200, which is going to be 496. And because P is dollar amount, that means the profit for 87 tickets is $486. Next question gives you the profit this time and asks you how many people. So how many people bought tickets? That would be the same as the number of tickets sold. So this time if you look at your equation, P equals 8t minus 200, this time you have a P value. So the P value is 1160 equal to 8t minus 200. So we want to isolate the term containing the variable, so we want to get rid of that negative 200 by adding 200 to both sides. And that's going to give us 8t equals 1360. And then we want to isolate the t by dividing both sides by 8 now, which is going to give us 170. So that means that for a profit of $1,160, 170 tickets were sold, or which basically means 170 people bought tickets. Okay, the next question says, for downloading torrent files, the company Demonoid charges, it should be N, annual fee of $34 plus an additional charge of $1.20 per gigabyte of data. Write an equation for the cost C of downloading G gigabytes of data. So the cost would equal $1.20 per gigabyte, so $1.20 times G plus your base charge of 34. And question B is, if you downloaded 85 gigabytes of data, what was the cost? So you use your equation again. And this time you know that G is 85. So you fill in 85 for G, and $1.20 times 85 is going to give you 102. Plus your $34, so that gives you a cost of $136. So 85 gigabytes of data will cost $136. And the last question says, if your account was charged $199.60, how many gigabytes of data was downloaded? So in that case there, go back to our equation again. This time we don't have a G value, we have a cost, so that would be, the C would be replaced with $199.60. And then you isolate the term containing the variable by subtracting 34 from both sides. And then you want to get the G by itself, so you've got to divide both sides by 120. And that gives you 138. So therefore 138 Therefore, 138 gigabytes of data was downloaded. That doesn't look like a W. Just use your imagination. All right, so these are the questions you can try in your textbook that will help you practice some of the topics in this section.